So, how do we find mass percent from chemical formulae? The key is you're going to use the molar mass, okay? So the mass percent of any kind of particular element, so let's call it element X, okay, is going to be the number of atoms of X, whatever that is, and that will be multiplied by the molar mass of X, whatever that is. And then you're going to divide that by the molar mass of the compound as a whole that it is in. So divide by the molar mass of the compound. And then you're just going to multiply by 100 to convert that to a percentage, basically. So essentially what you're doing is working out the molar mass that is just due to that particular element that you're interested in, okay? So don't forget to multiply it by the number of times that atom appears in the chemical formula, and then out of the total molar mass of the compound, how much is due to that one element, okay? So in this case, we've got methyl acetate, and we are asked to calculate the mass percent of hydrogen. So we are going to need the molar mass of the methyl acetate, so CH3 subscript 2, CO2. This is a tricky one because we've got parentheses and we've got carbons in more than one place. So how many carbons total do we have? We've got one carbon here, but it's times by 2, so it's 2 carbons plus another carbon there, so it's going to be 3 times the molar mass of carbon. And then for the hydrogens, we've got 3 hydrogens here, but that's times 2, so that's going to be 6 total hydrogens. Remember that because we're going to need that in a minute. We were asked about the hydrogens. And then we already took care of the carbon, and there's 2 oxygens, 15.999 grams per mole. So let's just make sure we got that molar mass of our methyl acetate squirreled away. So, we've got to turn the calculator on 3 times 12.011 plus 6 times 1.008 plus 2 times 15.999 gives me a molar mass for the total, the compound, 74.079 grams per mole. Don't worry about rounding or anything, that'll be fine. We'll round at the end, that's always good. Okay, so then to work out the mass percent of hydrogen, we're going to take the number of hydrogen atoms in the compound, which was 6, okay, times the molar mass of hydrogen, which is 1.008 grams per mole, divide by the molar mass of the entire compound, which we calculated to be 74.079 grams per mole. So grams per mole will cancel out and give us a unitless mass percentage. And then whatever that turns out to be, we're going to times by 100 to convert it to a percentage. Okay, so let's just get a... Oh, what did you do that for? No, I don't like that. Formatting is horrible. So mass percent hydrogen, let's do that again, is going to be 6 times 1.008 grams per mole. Repeat, divided by that 74.079. 74.079 grams per mole. Sorry, I've just wasted like 20 seconds of your video. So what is that going to turn out to be? 6 times 1.008, you probably already worked it out, divided by 74.079 should be times 100, 8.16425 blah 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 percent. Now we are going to want to round that, so we're asked to round it to the nearest percentage, so that's just going to be 8%. Okay, so always sensible to think about whether that sounds like a reasonable number. Now, just because there's more atoms of hydrogen in this compound than carbon and oxygen, you've got to think about their relative molar mass compared to the mass of hydrogen. Carbon and oxygen are pretty heavy, so it makes sense that it'd only be about 8% hydrogen. Okay, you want to do another one? Of course you do. Oh, this is a fun one, right? Hexanal. Okay, so we're asked for the mass percent of carbon. Brilliant. Okay. So first of all, we've got to work out the molar mass of the hexanal. So CH3 CH2, 4, CHO. So the reason that formula is written like so is to convey the structure. So it's telling you there's a CH3 unit on the end, then 4 CH2 units, and then it ends with a CHO. That helps organic chemists sketch these things out. And it definitely helps inorganic chemists like me sketch things out, because I wouldn't have a clue unless they wrote it like that. Okay, so that makes it hard for us in Gen Chem, though, to work out how many carbons and hydrogens and oxygens we're adding together. So there's 1 carbon in the CH3. There's 1 carbon in the CH2, but there's 4 of them. So 1 plus 4 is 5. And then another carbon in the CHO. So that is 6 total carbons. 12.011 grams per mole is the molar mass of carbon. And then we need to tot up how many hydrogens we have. So 1, 2, 3. And then we got the CH2, but those hydrogens are times 4, so 2 times 4 is 8, plus 3, and then plus the 1 from the CHO is going to be 12 hydrogens. Oh, I hope I didn't miscount. That would be embarrassing, wouldn't it? So 12 hydrogens in total. If I miscounted hydrogens, just put it down to there not being enough coffee in the world, and then we only have 1 measly oxygen in there. So we'll add those all together to get our molar mass of our hexanal, which should be 6 times 12.011. Play along if you like. 12 times 1.008 plus 15.999 gives me 100.161 grams per mole. So to get the mass percent of carbon, we are going to want to have the number of carbon atoms in the formula in total, which is 6, times the molar mass of carbon, which is 12.011 grams per mole, divided by the molar mass of the entire compound, so 100.161 grams per mole. And then we're going to want to multiply that by 100 to turn it into a percentage, because this will come out as a decimal and you're going to want it to be a percentage. Grams per mole will cancel out. So what do we end up with then? 6 times 12.011 divided by, I should probably press equals first because I didn't use parentheses, naughty me, divided by 100.161. I can push the button. Oh, sorry, my calculator is mutinying right now. Divided by 100.161. I didn't like that. I didn't give it parentheses. So times 100 gives me 71.950, blah, 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 blah. We're asked to calculate to the nearest percentage, so that is going to be 72%. Okay, so have a practice with those. Once you've done a few, it should be fairly straightforward.